Good evening everyone. Yeah. So what we discussed in the last class is we have started thermodynamics, and after that we have discussed basic terminology like what exactly systems, surroundings, all those things, and after that we have discussed thermodynamic properties like intensive properties and extensive properties. Okay, and after that state function, path function, and then later we have discussed this CP-CV relation, CP minus CV equals to R, NR or R we are writing now. So like this we are writing. So how we got this relation? What about CP by CV? CP by CV we are saying it as a gamma Poisson's ratio. Okay, so this Poisson's ratio values depends upon type of gas. For monoatomic gas it will be 1.66, for diatomic gas it will be 1.4, and for polyatomic, triatomic like that if I say, so it will be 1.33. Okay, it depends upon type of gas we are using here. Okay, today we will be discussing like work done in different different processes, thermodynamic process like isothermal process we have, adiabatic process we have. Okay, so what is the work done in those process, that is what we need to discuss today. Okay, yeah, so like this. So work done in various thermodynamic properties processes. One is isothermal process. So here we have three types again. Okay, we will be discussing these three types. Okay, and before this just tell me like what is the answer for this particular question. So just look at this question. See, the enthalpy change for the given reaction is given this much. So what is it? Delta U, it means internal energy change they are asking. So what is the relation between enthalpy and internal energy? Tell me first. So delta H is equals to so delta H is equals to delta U plus delta Ng RT. Okay, so now first find this delta Ng RT for this particular gas. So here what is the equation? N2 plus 3H2 gives rise to 2NH3 means number of like delta Ng means number of gaseous products minus gaseous reactants. So this will be products are 2 minus 3 plus 1, 4. This will be minus 2 now, right? So here I want delta U, that's it. So delta H minus delta Ng RT we can write. So from this delta H is how much? Minus 92.38, okay, kilojoules they mentioned, minus what about this value? So delta Ng is minus 2. So minus of minus plus 2, and R value how much I should take here? See, it is in kilojoules now. So R you can take R equals to 8.314 joules. I want in kilojoules, so you can write 10 to the power minus 3 into kilojoule per Kelvin per mole. You can take this as the universal gas constant value. So now 8.314, just for simplification purpose I am writing it as 25 by 3. So what is 25 by 3? 8 3s are 24. So we will get approximate value right now. So I am assuming that R is equals to 25 by 3 into T is how much here? Like 10 power minus 3 kilojoule per Kelvin per mole I am taking, and T is how much? 298 Kelvin here. So 298 Kelvin I am taking here. Okay, right. So try to simplify this, you will get the answer. So minus 92.38 plus, so here this will be 50. Okay, so I am removing 1 0 here. Okay, 100 we have here. So now this will be how much? 2.98 I have. If I multiply this number there, so this will be around 1 time I am saying. Okay, approximate 3 value. So that what we are going to get here? So 5 kilojoule we got. Okay, so overall what is the value here? Minus 92 plus 5 means, so how much it is? Minus, so 87.38 kilojoules will be the answer. Is this clear or not? Yeah. So like this we need to give our approach when we have delta H and delta U values and they are asking for the unknown value here. Okay, generally they will mention delta H and temperature they will ask delta U, or they will give this, they may ask delta H. Okay, very important relation it is. Okay, there are many questions based on this particular model. Okay, now here So tell me isothermal process. So what is constant in isothermal process? Temperature is being constant. So change in temperature will be dt will be. So if something is constant, then its change will be 0. That we know. Okay. So now what is the first law of thermodynamics we have? du equals to dq plus dw. Okay. So now in isothermal process, what is constant here? Temperature. So U means what here? Internal energy. Internal energy is directly proportional to temperature. Okay, but temperature is being constant here. It means its internal energy also remains same. Okay, so change in a constant value will be 0, means here change in U also 0. So for isothermal process, change in internal energy will be 0. Okay. So you can remember this as 0. So now what happens to the equation? dq equals to minus dw. It means what it is saying, see, plus dq equals to minus dw means whatever the dq means what? Heat change. W means, dw means work done. So whatever the heat you are supplying to the system, completely utilized for work. Okay, so now what if this is a system, you are supplying some q amount of heat. So this complete heat which you have supplied to the system is utilized for doing work. Okay, this is what you need to understand from this particular relation. Okay, so now dw means if I want pressure, volume, work. So what I can write? So dw means I have formula like minus p external dv. Right now, so dv means what? Change in volume, v2 minus v1 you can take. For example, here we have a cylinder having a movable piston here like this. Inside of this I am taking some ideal gas over here, okay, of 1 mole or something you can take. So now it will be having some pressure, P internal I am saying here P external. So in the formula we are taking P external pressure I am saying. Okay, so this P external V2 minus change in V means what? V2 minus V1, final minus initial. See, if external pressure is more, what happens to the volume of this cylinder? Compressed, right now decreases. So it is undergoing compression, so volume V2 will be lesser than V1. So depending upon that value, your sign will be changes here. So the negative sign in the formula indicates that is work done by the system in chemistry. Okay, so now we will do this particular thing for different process here. So isothermal free expansion. So free expansion, when it will be freely expanded, that whatever the piston you have seen here, this is going up very freely. It means external pressure will be not only less, it will be almost 0. When I am saying it is free expansion, external pressure will be 0. Or you can say isothermal expansion in the vacuum. So vacuum also there is no pressure now. So P external will be 0. P external value will be 0. So it means what happens to our work done formula minus P external dV means this value will be 0. So this will be 0 means work done will be also 0. Okay. So now during this case, if expansion is taking place in this isothermal process, free expansion is taking place. Now what happens to du? Du isothermal means it is 0. Then next du equals to dq plus dw I told you. This is 0, dw also you got 0, then dq will be also 0. So dq also 0, remember. Okay, and the next one more term we are going to study, something like called entropy. So entropy means disorderness of a system we will be discussing. Okay, so now in the exam they will ask you the question like which are the following parameter will be 0 during isothermal expansion, like that they will ask you. Okay, so whenever you are seeing a word called expansion, its entropy will be increases. What I am saying? Entropy increases. See, just remember, I am keeping the gas molecules in very closed container. What happens? They will be closely packed. Right now, if I increase the volume, then their movement will be more. So randomly they will move here and there. So randomness is increasing. So disorderness is increasing. So entropy is nothing but measure of disorderness. So entropy also increases. Like that you can remember. For expansion, what happens to the entropy? Increases. You can remember that. Okay. So now for the same process, what about enthalpy? dH. For isothermal process, what about enthalpy change? 0. Why it is 0? So how can you get this 0 value? See, dH equals to du plus, so first of all you need to know what is the enthalpy and internal energy relation. H equals to U plus PV, we have like this. Okay, so now instead of writing PV for ideal gas, PV equals to RT, I can say ideal gas equation. So in the place of PV I can write RT. Okay, so dH is equals to du plus R is a constant into dt. Okay, so now isothermal process change in temperature will be, so this value becomes 0. So internal energy already 0, therefore dH will be 0. Remember these things. Okay, next. Here we have reversible expansion. Look at here very carefully. We will discuss this clearly. So now W equals to minus P external dV we are writing. Okay, so for ideal gas, what I have, PV equals to RT. So I can say RT by V, as taking P as RT by V. So why I am taking this one? Reversible case, see, you should ask me a question, sir, you are saying P external but you are taking ideal gas inside. How you are taking this inside ideal gas? I mean, this, instead of taking external pressure you are taking internal pressure. Why? Because for a reversible process, reversible, when we are saying reversible, the from the pressure from inside and pressure from outside is almost same. That's why we are saying it is a reversible right now. So P external will be considered as almost having equals to P internal. Pressure, external pressure and internal pressure are almost equal in the case of reversible process. Therefore what happens here? So what happens here? So W equals to, I can write P internal as ideal gas, P ideal. So that is nothing but RT by V dV. Can I write it like this? Yeah. So now R, T are constants here. Okay. So now what happens here? So V means 1 by V dV. Integration of 1 by V dV, what we will get? So if I do integration for this, work done change. Huh?
RT can be written as PV.
RT?
Can be written as PV. Then V can be cancelled.
What you are saying, man?
RT can be written as PV.
Again you will get only P now, same thing you will get. Okay. So now RT by V into dV I can write like this. So 1 by V dV, integration of 1 by x dx is ln x. Okay. So we will get like minus sign is as it is, I am writing here. Here also minus RT ln V. Okay. We are saying expansion now. So expansion means there will be change in volume. Initial volume is V1, final is V2 I am saying. So here V1, V2. So now what happens to this equation? Minus RT ln V2 minus V1. It means ln V2 minus ln V1. I can write ln A by B form. Okay, ln V2 by V1 form I can write. Okay, so here work done will be W equals to minus, see this ln I can also write log terms 2.303 RT log V2 by V1 I can write. Okay, so now in terms of pressure if I want to write the same equation, so PV equals to nRT is there now, so but PV equals to RT I am saying. Isothermal process now, what is constant here? Temperature. R is already constant. Okay, for a particular gas P1 V1 is constant, it means these both are a constants now, it means which is equals to P2 V2. In the place of V2 by V1, what I can write? P1 by P2. So what happens to the equation now? W equals to minus 2.303 RT log P1 by P2. Okay, like this. So at least write this final conclusions, formulas, so that it will be useful for solving questions. Okay, now I will give you one question. Okay, we will complete irreversible process, then we will see into some questions. Okay, so irreversible, just take it as P equals to minus P external dV, V2 minus V1. Okay, so in the place of V2 minus V1, see I can write PV equals to RT for 1 mole. Okay, so here if it is for n mole, you just multiply with the n, nRT it becomes. Okay, so now here I just want V, RT by P I can write. Okay, so at volume V1 it will be RT by P1 because R and T are constants. Okay, at volume V2 RT by P2. Okay, so it means you can substitute these values over here. So what is the final output we will get from there? Tell me. W equals to minus P external. See, okay, first of all we will substitute this, then we will discuss further. Okay, in the place of V2 RT by P2, in the place of V1 RT by P1. Okay, like this we can write. Now for example, here I have a piston over here, this is a volume V1, expanded up to here, volume becomes V2. Okay, so now at V1 value, what is a P? P1, pressure is P1. At V2 value, pressure is P2. See, this piston moved up from here to here and it is stopping here, means internal pressure and external pressure are equal at this condition. It means at this this white color position. Right now it means this P external and final pressure will be same. Okay, so that I can write the formula as W equals to minus P2, see RT taking common here, P2 into 1 by P2 minus 1 by P1. Can I write it like this or not? Is this clear or not why I am writing? Yeah. So after this you just keep it inside minus RT. So what happens? P2 by P2 is 1 minus P2 by P1, like this. Okay, so write all these formulas, these final formulas at least. Okay, so please try to make your own notes from here, it will be useful. Over? Yeah. So now tell me, what's your answer for this question? Calculate the work done during the process when 1 mole of ideal gas allowed to expand freely into vacuum. Vacuum. So whenever the word is vacuum, it's a free expansion. P external pressure will be 0, therefore work done will be also 0. Is this clear or not? Simple. Okay, so this question is asked multiple times, so you just need to use your common sense what they are saying here right now. And next, now we will be discussing based on a question based on reversible process. Okay, so now take the question. The work done when 1 mole of ideal gas, the work done when 1 mole of ideal gas expanded from 1 liter to 10 liter at 27 degrees Celsius. At 27 degrees Celsius. Tell me. Why 0? It's a reversible process. I am saying na first itself. It's like reversibly you can write if you want. expanded isothermally and reversibly, you can write. Simple formula substitution you can do. So I want your answer in kilojoules. Got the answer? So what we'll do here, tell me. So work done will be equals to minus 2.303 RT log V2 by V1. That's it now. So next minus 2.303, and what is the temperature I mentioned? 27 degrees. So you should not take it is in degrees Celsius, you should convert into Kelvin. Why? Because R value we are expressing in kilojoule per Kelvin per mole. So R mentioned in kilojoules Kelvin, so this should be 300 Kelvin. Okay, here take it as 300 Kelvin multiplied with R. So what I told you, 25 by 3 you can use here. Okay, for simplification purpose. Okay, what is the units? I told you kilojoule per Kelvin per mole into log V2 is 10, V1 is 1. So log 10 is 1. Okay, so this value will be 1. Okay, and the next here we have 2.303 into 25 kilojoule per Kelvin over Kelvin per mole is also over. Okay, 1 mole I told now. So that's it. This will be the answer. So just multiply this, you will get your answer. So into 100 is there now. 200. Okay. So this will be into 10 power minus 3 here you have 10 power minus 3. It means 2.3 into 2.5 kilojoule will be your answer. Okay. What is the work done? Work done by the system now. So minus 2.3 into 5.5 kilojoules. Okay, simplify that, that will be your answer. Okay, and next write one more question. 8 grams of O2 gas expanded isothermally reversibly from 2 liters to 20 liters at 27 degrees Celsius. I want your answer in calories. Or in kilocalories. I want your answer in kilocalories. Simple substitute in the formula, you will get the answer. What is the R value in kilocalories? So R is equals to 8.314 joule per Kelvin per mole. If it is calories, 2 calorie per Kelvin per mole you can take. I am asking kilocalorie now, multiply with 10 power minus 3 becomes kilocalorie per mole per Kelvin. Okay, so take this final value here in your question, you will get the answer. So what is the answer? So simple now. So R is W equals to minus 2.303. What I told you? How many grams I told you? So it means you just take nRT log V2 by V1. So how many moles I have given? 8 grams means how many moles it will be? Calculate that. So W equals to minus 2.303. N represents number of moles. Number of moles I can write given weight by its molar mass. Right now, so what is the given weight? So 8 grams. What is its molar mass? O2, oxygen, 32. So it will be 1 by 4 into, what is the R value we have? 2 into 10 power minus 3. And next, temperature is how much? 300 Kelvin. So log again 20 by 2, again 10, directly given like this. Okay, so now next, this will be 2. Okay, so this will be 0.3. Okay, so minus 2.3 into 0.3 by 2. That's it now. Kilo calorie. So you can simplify this. Okay, so how much it will be? 0.69 by 2. So this will be 0.345 kilo calorie minus 0.345 kilocalorie. Is that clear? Okay, let's move forward. So it is clear now isothermal process. Next, we'll discuss adiabatic process here. So what exactly adiabatic means? So for a system, if I consider this is a system, there is no exchange of heat between system and surroundings. So Q will remains constant in adiabatic process. Whatever the heat present in the system, that will be constant. There is no exchange of heat, I am saying. So change in heat will be 0 for adiabatic process. Okay, so next, again free expansion, all this there is there. So free expansion means work done will be 0 here also. Next, reversible expansion we need to study. Okay, so first law of thermodynamics, what is that? Du equals to dq plus dw. In isothermal process, du is equals to 0 in that case, but here what is 0? dq is 0. Therefore what happens? Du equals to dw. It means what it is saying, work done, like work done by the system means what is the sign we should indicate? Negative. It means whatever the work done by the system, if work is done by the system, it should be indicated with a negative symbol now. So this is work is done by the system by utilizing its internal energy. So now what happens to the internal energy if system is doing work in adiabatic process? Internal energy of the system decreases. Okay, now for example, the process is taking place at 300 Kelvin. Work is done by the system. Now what happens to the final temperature? Decreases. Why it is decreases? Because work is done by the system by utilizing its internal energy. Therefore system's energy decreases, therefore system become cooled. So in adiabatic expansion, what happens to the system? It will be cool. So system cooling takes place, you should say. Okay, is that clear? The term is clear or not? Yeah. So now here work done will be equals to dw equals to du, I am writing dw equals to du. So what we have during when we studied about CV, heat capacity at constant value, molar heat capacity at constant volume is equals to du by dt we have studied. So from here du I can write CV dt right now. So in the place of du I can write it as CV dt. Why I am writing like this? Because I want work done. Okay, so dw equals to CV dt I am writing. Okay, so now again in the last class also I have discussed, now also I am saying here Cp minus Cv equals to R. Okay, so Cp I am dividing again with Cp or Cv, I am dividing this with Cv. So what it will gives? Cv it is written. So Cp by Cv is gamma, I told you. So it is gamma, this will be 1. Gamma minus 1 equals to R by Cv we got. Then from here I can write Cv equals to R by gamma minus 1. Okay. So wherever we have Cv, that can be replaced by R by gamma minus 1. So dW equals to R gamma minus 1 dt. So this is nothing but R gamma minus 1 T2 minus T1. We can write like this. Okay. So now in the place of RT, PV equals to RT I can write now. So in the place of RT I can write see, if it is T1 it becomes RT1 becomes P1 V1. Similarly if it is T2 P2 V2. So here I can replace these things as P2 V2 minus P1 V1 by gamma minus 1. These are the formulas for adiabatic process. Okay, if they give temperatures you use this, if they give volume and pressure use this. Okay, so now what about gamma value is I told you, for monoatomic gas gamma equals to 1.66, diatomic 1.4, for polyatomic 1.33. Okay, remember these values. These are very important while doing adiabatic process questions. Okay, so they will say, just they will give you a monoatomic gas undergoing reversible adiabatic expansion. So it means gamma value should be taken as 1.66 at some temperatures they will say. Okay, so now I will be giving you one question here. Yeah, so along with this we have some other formulas also for adiabatic process, work done. So PV power gamma equals to constant, you can remember. Okay, so PV power gamma equals to constant. Okay, from here, yeah, so this formula we have done, P2 V2 minus P1 V1 by gamma minus 1. Okay, so for 1 mole I have told you dW equals to du equals to Cv dt I told you for 1 mole. For if it is n moles, NCV dt, or you can say nR gamma minus 1 T2 minus T1. This is dW. Okay, now just try this question. We will come back to this. Tell me what is your answer for this question? Fast. Very easy. Formula. So try to make your notes on regular basis so that you will be in connection with the things. Done? Yeah. Tell me your answer for this. Very simple question it is. 2 moles of an ideal monoatomic gas are allowed to expand adiabatically and reversibly from 300 to 200 Kelvin. Okay. The work done by the system is, what is the formula I should use? Work done, dW equals to, see they given Cv form, direct Cv value is given, so I can just use NCV dt. Why I am saying NCV? They are saying 2 moles. Okay, so 2 into 12.5 joule Kelvin inverse, mole inverse they mentioned. So here 2 moles is there, mole inverse cancel, and temperature difference is how much? T2 minus T1, 300 minus 200 is, see again T2 minus T1, T2 is how much? T2 is how much? 200. minus T1 is 300. So what we know, during adiabatic expansion, heating takes place or cooling takes place? Cooling. That's why initial temperature is higher, 300. Expansion na, so final temperature is 200. So what happens to temperature? So cooling only na. So that is why we are going to get here a minus symbol here. Okay. So minus 12.5 into this one means 25. Okay, into 100 joule we'll get. Okay. So they are asking, they are given all options in kilojoules. So it means multiply with 10 power minus 3. So it will become minus 2.5 kilojoule. That's it now. So option 2 will be our answer. Yeah. So this simple question you tell me for isothermal process. This is a PYQ again, simple PYQ, right? See, what is your answer now?
No, what is 1 liter bar?
Here they mention now 1 liter bar means given 1 liter bar is equals to 100 joules. Why it is? Because your answer is in terms of joules. So based on that,
You have to convert bars into joules.
yes, that's it. Over, done. See, W equals to minus P external into dV. Okay. So what they are saying, under isothermal condition, a gas at 300 Kelvin expands from V1 to V2. So V2 minus V1 is change in delta V is change in volume is 0.15 liters. Okay, against a constant external pressure of 2 bar. So 2 bar. Okay, so that we will get 0.30. This is bar into liter. So liter bar we got. Okay, so minus 0.30 liter bar is nothing but 100 joules. Okay, into 100 joules. So this will be 30 minus 30 joules. That's it. So we have first option. Very simple now. Okay. Write this. If it is done, we will move forward. Yeah. So in the last class, I have given you the isothermal process and their graphs, like PV versus graph, like isotherm here I can say. So this is at isothermal condition. So at isothermal conditions, what are the graphs we will get? So this is for Boyle's law, we will get the graph. Okay. And what about this here? Temperature is constant. Okay, it means this is also for isothermal only. Okay, temperature is being constant. See, temperature constant means what is it? Isothermal only. Here also temperature is being constant. See, so this is also for isothermal. And adiabatic process means these are the curves we will get. Next, isochoric means these are the, what is constant? Isochoric means volume is constant. See, that's why volume term is remaining constant as pressure increases. Okay, here also see volume is remaining constant here. Okay, and P versus T, as temperature increases, pressure also increases. Okay, at constant volume. Okay, so this is isobaric curves. Next, okay, now look at here, we have some graphs over here based on the previous understanding. So now again in physics you will be studying something like Carnot engine. Okay, Carnot cycle. Okay, so these are the graphs you are going to use there. See, from here to here, what is this process? See, it is changing like this. So I can say isothermal, or see isothermal, see volume is expanding now, V1 to V2 it is becoming isothermal expansion. Okay, again this is also expanding, so that is adiabatic expansion. Okay, if it is going this side means volume is increasing, expansion. Next it is going back, it means it should be compression. And what it is similar to the above one now, so isothermal compression. Again from here to here, adiabatic compression. Okay, 4 process will be there in the graph. Okay, right. Okay, next we will be studying about thermochemical equations. So during chemical reactions, what is the heat change? For example, reactants are converting into products. So during this process, what is the enthalpy change? That is what we are saying, enthalpy of reaction. Okay, so for example, if enthalpy of products, enthalpy of formation of products and reactants are given, so what you need to take is enthalpy of products minus enthalpy of products minus summation of enthalpy of products minus summation of enthalpy of reactants we can take. Okay, if combustions are given, so which is undergoing combustion? Reactant is undergoing combustion now. So take here first enthalpy of summation of enthalpy of combustion of reactants minus, these are not undergoing combustion, these are undergoing formation, that's why I am mentioning here minus. So enthalpy of combustion of products like this. Okay, so this gives you the, again if I multiply this equation with n, I mean there is some stoichiometric coefficients like n, m are there. So what to do? So whatever the stoichiometric coefficient here you are seeing, multiply that with respect to reactant or product, something like that. So multiply here n, here m, like that. Okay, is this clear or not first? Yeah, move forward with few things. This enthalpy of reaction, see enthalpy of reaction will be affected by, these are the factors. What are the factors influencing? So it depends upon physical state of reactants and products. Okay, see for solid to liquid, liquid to gas, for this conversion tell me which is in highest energy state. For a particular substance, if gas, that will be requiring high energy now. Okay, so it means their physical states also, see product formed here is gas, here is liquid. So see some amount of energy is converted here. See when it is when it is in liquid state, it is releasing 68.32 kilocalories of energy is released, but in gaseous state it is releasing only it means around 10 joules, 10 kilocalories of energy is utilized for conversion of liquid to gas. Okay, it means its physical states are impacting, okay, affecting. And the next allotropic forms also. So diamond and graphite, so these are the allotropes of carbon. So those are also having different values. So allotropic forms also affects. The next enthalpy of reaction differs when one case in dry substance, other cases some other, like see here we have gaseous form, here solution form. Okay, so now here also this whether it is dry or wet, that is also impacts here. Okay, these are the 3 factors which are important to be remembered. Okay, so now enthalpy of reaction means what we can say, formation means amount of heat absorbed or evolved when 1 mole of a particular substance is directly obtained from its constituent elements. Formation they are saying. So if they are saying about formation of CO2, so CO2 comes from, what are the constituent elements? C plus O2. Okay, what is the standard state of carbon? Graphite. Okay, it should be in graphite form, and oxygen will be gaseous state. Okay, like this it should be. Okay, see graphite and oxygen in O2. Okay, so whatever the enthalpy change during this process is indicated with this much. So tell me what is the symbol here? Negative. Exothermic or endothermic? Exothermic. Heat is released by the combustion of, by the complete oxidation of carbon here, graphite. Okay, and for calcium also, see what you need to remember, whenever they say formation, that formation should happen from where? That whatever the product we are seeing, that should be formed from respective elements. From, like if I say formation of water, So from where it should be comes from? Hydrogen. What is the standard state of hydrogen? Like diatomic form in the gaseous state right now. So H2 gas plus O2 gas, here I can take half, and only 1 mole formation. See how many moles it is. So you should take only for 1 mole formation how much it is required, like this. Balance the equation as per 1 mole. Okay, so now if I want to write enthalpy of reaction for this, tell me. So delta H reaction I want, formations are given. So what is forming here? Water. So enthalpy formation of delta H formation of water minus delta H formation of, see only water is forming now, so only that one. After that if anything is formed you should write plus that thing. So only this one is there. So after that reactants now. So reactants are deforming now, that's why I am just taking here minus. Okay, so enthalpy formation of H2 minus plus enthalpy formation of O2, and what is the coefficient they have mentioned? Half, and here this will be 1. And you know, just remember the standard here, this is enthalpy formation I am saying. Sometimes it is given as standard enthalpy of formation. So standard enthalpy of formation means if temperature is not mentioned, consider it as room temperature. Okay, normal 25 degrees Celsius. If they mention any temperature, that is its standard temperature. Okay, and 1 atm pressure. So at this particular condition, what is the standard state of hydrogen? H2 in gaseous state. So the enthalpy formation or enthalpy combustion values will be equals to 0 for H2 in its standard state. For any species, if it is in its standard state, then its enthalpy formation and combustion will be, standard enthalpy formations and combustions will be 0. Okay, so for carbon in graphite form you should say it as 0. In diamond form it will not be 0. Okay, so here I have anyways. So just read this. If the heat of, it is a heat absorbed, enthalpy of formation means it is a heat absorbed or released when 1 mole of compound is formed from its constituent elements under standard elemental form. Okay, standard elemental form for O2 is what? Oxygen is what? O2 only. For carbon it is graphite. So graphite. For sulfur it should be rhombic. Okay, for phosphorus it is P4 or P4, like phosphorus white they will mention. Okay, for bromine it will be in liquid state at standard condition. Okay, whereas chlorine it will be gaseous state only. Okay, so hydrogen it should be gaseous state. So their values are 0 here. So if they mention delta H not F of Br2 gas, will it be 0? Bromine gas? No, because what is its standard state? Liquid. So then only it will be 0. In other cases non-zero, some value will be there. Okay, right. Now tell me for this question how can we solve? This is the one last question I can discuss here. Yeah, tell me how can we solve this question? The enthalpy formation of CO2, formations of CO2, CO, H2 are given like this. Then the enthalpy change for the given reaction. So enthalpy formations are given now. So then enthalpy reaction will be taken as products forming, whatever the things forming minus deforming. Okay, so enthalpy formation of CO plus enthalpy formation of what? H2O minus enthalpy formation of CO2 plus enthalpy formation of H2. H2 is not given. Why it is not given? Because in its standard state that will be, standard enthalpy formation will be 0 for hydrogen in its standard states right now. So whenever this is standard, you just take them as like they just represent them as like this, like this, like this. So substitute the values over here. So what is the value for CO? See, second value, second minus 110.5 plus H2O minus 241.8 minus this one So minus of minus, here it will be minus 393.5 and this is 0. So what I can say? This will be 13. So 2, 5, 3 minus 352. Okay, and here plus 393.5 kilojoules. Okay, so what is our answer?
41.
So it will be 41.2 kilojoule. So we have an option 2. That's it. Okay, one last question for you as a homework. Yeah, so try this question. This is JEE mains question, but I know you can able to do this. Write the question. Done? Yeah. So this is about the class. If you have no doubts, then I can close up.